In this video, we are hammering down. So I am currently doing 121 amps of discharge. Coming up in this video, we have a battery by XZNY. This is their 25.6 volt, 100 amp hour, or more commonly known as a 24 volt battery. This battery features the chemistry of lithium iron phosphate, which is a well-known chemistry for its longevity. So starting off, we have the battery here. We get a user's manual, which we will look over in a second. For our hardware, we get a bag of bolts. We have a longer bolt and a shorter bolt. Now the longer bolt, I'm not sure how many terminal lugs you're going to put onto your battery, but this is going to allow you. So with this larger bolt, you'd be able to put about 1/8 of an inch worth of lugs onto this battery. So that's a little bit excessive in my eyes. Okay, so let's take a closer look at this manual. I found something interesting in it I'd like to share with you. And something caught my eye about the battery parameters here in the user manual. And as you can see here, they have the rated capacity at 200 amp hours. Now this is a 100 amp hour battery, so then that puts into question the rest of the parameters on this page. For a maximum continuous charging current of 120 amps, I highly doubt that that is correct. Typically on lithium iron phosphate batteries, you will only see a 1C charge or discharge rate. Once I open this up and take a look at the BMS, we will confirm if it can do 120 amps or if it's 100 amps. Hopefully it's printed on the BMS. As well as the maximum continuous discharge of 120. That's not really out of the realm of possibility, but the charging current of 120 amps I'm going to say is. And you can also see we have 2,560 watt hours, that's correct. And here we have a maximum load of 3,072 watts. Now again, that brings into question, because of the 200 amp hour capability and the 120, I'm not too sure if those parameters are correct or not. So we have a few questions we need to answer, and the only way I'm going to be able to do that is to open up this battery. Now, if this battery can in fact do 120 amps of discharge, and we can get 3,000 watts of power being able to be pulled from the battery, that means that we could use, let's say, a 24 volt Growatt, 3,000 watt, and power this at maximum load for an hour, which would be pretty cool, but we're going to have to open it up and take a look. So I'm really wanting to open this battery. First thing we're going to do is a capacity test, get that out of the way. And then I'm going to open it up and we'll take a look and do a little bit more research. So I'm actually starting to think that this actually can do 120 amps of charging and 120 amps of discharging. They have it printed on the actual case. You can see here we have the 100 amp hours. I think maybe it was just a misprint of 200 amp hours in the manual. You can see here we have maximum load inverter power, and that's over 3,000, so 3,072 watts. Okay, I've got my tester set up and I have my app running for my smart shunt. So let's power up the inverter. Okay, and you can see there we're sitting at 27.37 volts. Now that's resting at the top end. So we are ready to start our discharge test. And you can see there the standby consumption of this inverter is 5.19 watts. That's actually pretty good. Okay, let's plug in my power source. Give that a few minutes. Okay, you can see there we are discharging at 31.8, around 31.5 amps, so that's going to be perfect. This test should take roughly about 3 hours. So I'm going to let this run and then I'll be back with the results and we'll see what we get. Okay, we are still discharging and we are past the 85% mark. So there is less than 20% left in the battery and it did not shut off. We are still discharging. So I don't believe there is a protection at around 20%. I'm not sure if you've seen Brad's video, but he had his battery disconnect at around 20%. This battery has not disconnected. So I'm going to let the discharge test continue. Looks like we have about 46 minutes left and the current is down to 19 amps. And the reason why we are now discharging with 19 amps instead of the 46 when we started is because I am discharging through the inverter which is then running over, don't mind that plane, which is running over to a battery charger, which is connected to my larger 48 volt bank. So that charger has lowered its charging amperage, so that's why we're only discharging at about 20 amps now. All right, we have hit low voltage disconnect. As you can see, my volts are at about 3.19 volts. That's because the BMS has disconnected. And we are sitting at 105.206 amp hours out of a 100 amp hour battery. So we are above the capacity, and this tested all the way through. We did not get a hiccup. It just went all the way through. So that's great. Now I've got the battery open, so let's take a closer look. Okay, starting here from the posts, we have our positive post and our negative post, and we have 5 12 gauge wire, and they are rated at 105 degrees, 600 volts. And then on the positive, we have a 6 gauge wire, and the temperature rating is 200 degrees. Now already I can tell, if you look at this crimp, I'm going to call that the butterfly effect. To me, it looks like they used a die that was too small for this gauge wire and for this size of lug. The crimp came out sort of like a butterfly. Don't mind my horrible drawing, but it sort of came out like this. So you've got a space here and then a butterfly coming out and a butterfly wing coming out. So you can see that on this crimp here. We can also see how it's flat here. That's on the crimp. And again over on this crimp right here. So the way this battery is set up is we have our positive that comes down, and then we have 4 cells stacked in series coming up, and this is the main positive, which then comes over to this side, and then we have 4 cells stacked down on this side. So I was able to get the QR code on my scanner app, and I'll put that up on the screen now. So you can see these are GFB cells, which are really good cells. So you can see from our negative, which runs down into the BMS on this side. See if I can remove this. And the fish tape wants to come with it, so I'll bring it with it. So it comes onto this side of the BMS, which is the P negative, runs over to the B negative, and then these 5 12 gauge wire run down to the battery. So what I noticed on the battery cables as they come out of the B negative is they run down here and they spliced a bolt in here. So if you can see that, that is a battery lug and a battery lug connected by a bolt and then heat shrink put over top of it. And then that runs down to the battery negative. Now, one thing I don't like about that is it is really close to this battery positive over here, and it can actually rub against it. So if you had vibration, that shrink wrap could rub off and then have contact with the positive terminal that's over here. So when I do put this back together, I'm going to pull this battery cable back, and this hole here on the BMS, I'm going to put a small zip tie through it and have it here so that it can't migrate over here to the positive like that. So it will hold it back over in this direction. That's what I'm going to do when I put this battery back together to make it safer. So you can see here at the BMS we have XZ21FOB663X6.0, and moving down you can see that we have 100 amp and 100 amp. So I'm assuming that is 100 amp charge and 100 amp discharge. Now the manual said it had 120 charge and 120 discharge. So the BMS is only rated for 100, so there's a bit of a discrepancy there. And as you can see on Google Translate, it did the best it can, but specification 8S, board current charging 100, it said an L, but that was a 1, and then discharge 100 amps. Wiring method, same port, so I'm guessing that's for charging, because some BMSs have a separate port for charging, but not this one. Okay, and the way that these cells are connected, you can see there's a copper screw that goes inside of the cell. There's no post on these cells, it's just threads down into the cell. So I'm not too sure how good the copper screw is going to hold up over time, but I definitely would not have used a copper screw. I would have used something with a tin plate, similar to the buzz bar that is copper tin plated. Let's test. We do have a temperature sensor here, so let's pull that out and test it for cold temperature and overheat protection. Okay, cold temperature protection test. I have my bench power supply charging with roughly 4 amps. Now I'm going to try and do this here. I was just touching the probe, so it's showing 29.1 degrees. It will cool down if I give it time, but I want to do this test. So let's force cool it. And we are dropping. We are now below freezing according to my probe, but my probe might be sensing it quicker than the other one. I'm going to come off for a second. Come back on. I want to try and hit it at 0 degrees. Okay, now I'm at -8 degrees and temperature protection just started. So we've disconnected from the power supply and I'm going to heat this up a little bit, try and cool it right again. -5, okay. So right around -5 it was disconnecting. I would like to see that a little bit closer to 0 degrees, but it might just be because my probe registers it sooner than the BMS does. And now it's time for high temperature protection. And there it goes, just disconnected. So we do have low and high temperature protection, which is great. And cool it down, and we have charging again. So next I'm going to reconfigure, and I'm going to do what I will call a hammer down test. So let me reconfigure everything and we'll hammer down. Okay, I'm now set up. This is actually day 2. I got a little sidetracked last night with a barbecue. So I have the battery set up. It is now charged up to full. I have a Growatt 3000 watt inverter. So this is going to provide me with a big enough load that I can test the amp draw on this battery. I know my drawing probably wasn't good, but basically that's what I'm talking about when I say the butterfly effect. So you can see it's flattened out on the sides. It's not a nice like octagon type shape. It's not crimped with the proper size die. So that's demo on that. Okay, now it's been a very long time since I've started up this Growatt. And it fired up first try, so that's great. So I've got an amp meter here. We're gonna keep track of the DC current. So I have 2.2, actually the inverter just kicked on, so 2.3 amps coming out right now. Let's power up some loads. Now I've also got a thermal camera. So this is a camera that hooks onto your cell phone through your charging port. This is a USB type, and they also have a lightning charge cable type, I think it's called, for the iPhone. So very handy little tool here. I'll leave a link in the description. Got about 72 amps. Now to get this closer to 100, it's going to get a little bit loud in here because I'm going to be turning on my heat gun here. We have just under 120 amps. So that is right at the max that was stated on the manual that it can handle 120. Let's actually bring that down a bit. That's actually not, so let's leave it at 73 amps. So I'm gonna discharge at 73 amps. I'll leave this run for about 5 minutes and I'm gonna periodically check with my heat camera. If I see anything worth recording, I will record it. Reset up the camera. You can see 105.2, 0.3-ish. Oh, going up a little bit. About 105 to 106 amps there on the clamp meter. And we are about 47 degrees on the cabling. The BMS is again the same, about 47, 48. If you look at the temperature at the top right, that's what the cursor is on. Oh, our bundle of wire is starting to heat up. I've seen 50. And that bolt-on piece there, not too bad, 45, that's staying cool, but it might be the shrink wrap is hiding the temperature. So the BMS over here, about 44. The BMS on this side, we're seeing about 48, 50. So the BMS is starting to warm up. Okay, I'm going to increase the amperage, hopefully around 120, which is the rated max discharge, continuous max discharge of this battery. Ooh, 22, 21. And on the Growatt, so the Growatt, we are 2.65 kilowatts. So that's about 2,650. At the battery, we are at 118. So 118 on the Growatt. So the Growatt is telling me that we're actually 118 amps. Man, this is so cool. Ooh, 57.6. I think the thermal switch is probably gonna break at 60 degrees, or maybe it's 75. I can't remember what the thermal switches typically are. Maybe it's 75 degrees. So we have almost 60 degrees on the cabling. Oh, we do have 60 degrees. I see 59. Check the cabling over here. Not too bad. The BMS though, 57, 58.4. The bolts down inside here seem to look okay. They're not overheating. It's just mainly the conductors, so the 12 gauge wire and the BMS seems to be where it's at. See if there's any individual. Yeah, that BMS is really starting to heat up now. 59. Yeah, 59.2 on the cables. So it's almost been probably about 10 minutes of running this at 120 amps. Now keep in mind as well that this battery would probably get hotter with the lid on and sealed. Now that I've got the lid off, this is allowing a little bit of cooling, so this isn't exactly a perfect test of temperature. We are heating up. So we have 61.6 there. See if I spot any hot spots here. 61. 61.5, not too bad. Cables are starting to get really warm though. The cells look okay, they're holding up. It's mainly the BMS and the 12 gauge wires that are heating up. Cells look pretty good down in there, they're not heating up at all. Check this side. Oh, you can see the post down there is about 40 degrees, so the battery's starting to internally heat up. Oh, there you go. That's the bus bar there. So the bus bar's heating up about 44, 41, 43. So the bus bars down inside are starting to heat up. Okay, I'm gonna stop the test here. So we are still discharging, but I'm gonna shut it down now. So it was probably roughly maybe about 20 minutes of 120 amps of a discharge, and it actually held up. I'm kind of surprised. I thought for sure this was gonna fail. So we were pushing right around 2,600 watts through this battery. We didn't quite do the 3,000 watts of discharge, but we were really close. So I'm just gonna let the Growatt, I'm gonna leave the fans run for a minute, let it cool down, and then I'm gonna shut this unit off. And then I will do my final thoughts after that. Okay, that was a rather interesting test. I really enjoyed that. I should do more of those tests more often. So my likes and my dislikes. I do like that it passed my capacity test. It can pass my hammer down test. And it overall looks like a pretty good battery. Some of my dislikes of the battery are the crimps, the way that they use the wrong die, and they've got the butterfly effect, I'll call it. That I wasn't too excited about. Another thing is using copper screws on the posts. I'm not sure how well that's going to hold up over time. I would have liked to have maybe seen a stainless steel bolt in there instead of a copper bolt. A jumper cable. So this cable connecting a 4S pack to a 4S pack, making a 48 volt or 8S pack, I'm not excited about it because this is going to add resistance between the two packs that are in series, and it could cause one of the packs to drift off of voltage from the other pack. And depending if the BMS can keep up with the balancing of it, you may get a diminished overall capacity over time, more and more and more as it builds up. Each crimp is going to add a resistance. But I see why they had to do it. They wanted to fit this into a small package. Another thing I didn't like was these 12 gauge wires here, the 5 of them, running into a bolt in order to lengthen the wire down to the battery negative. I didn't like that, and they just kind of Mickey Moused it with heat shrink to cover the bolt. I have fixed it with zip tying it down so it can't move, and also putting a bit of tape to secure it. But what could happen is it could wiggle side to side, and it could rub and cause contact with one of the positive terminal posts here. The BMS rating, so on the BMS itself, it's saying 100 amps charge and discharge, but then the rating on the battery is saying 120 amps. Now we did do about 15-20 minutes, I think more or less 20 minutes of a discharge at 120 amps, and the BMS started to get warm on the heatsink. It's not ideal, so I would stick to what the BMS says and try and just do 100 amps of discharge continuous. This fish tape on top of the heatsink. So this heatsink needs to dissipate heat. By putting an adhesive fish tape over it, it's going to cause that heat to get trapped. But other than that, I mean, the battery did perform pretty well. It's a smaller package than what we're used to seeing. For light duty use, I would say I would not recommend the 120 amps of continuous discharge. But yeah, I think this battery actually turned out to be pretty good, except for those minor things that they could clean up. If they could do that, they would have one hell of a battery here. And again, as always, thank you very much for watching. If you enjoy this content, don't forget to hit the like button before you go. It really helps the algorithm on this channel. And as always, thank you. Bye.